Hello developers. As a UI developer, I share the concepts and challenges I've encountered in real-world projects. And today's project is not just a website. It's a visual journey that responds to your scroll, as if you're walking through a cinematic story. Now imagine this. The sky gently fades in. Mountains start sliding in from the background, and a lone figure standing at the edge emerges with presence. As you scroll, new content reveals itself, scene by scene, just like chapters in a movie. We've built this experience using clean Semantic HTML, layered visual design with modern CSS, and scroll-triggered animations using G-Sap with ScrollTrigger and Lenis Smooth Scroll. But here's something to think about. Can a simple scroll action feel like a guided hiking adventure? And how do we bring that illusion to life without writing overly complex code? In this video, you'll learn how to structure your HTML into semantic, meaningful sections, how to layer your background visuals using only CSS, how to animate elements on scroll using G-Sap timelines and ScrollTrigger, and how to integrate Lenis for buttery smooth, fluid scrolling across devices. Each effect is custom-tuned, from the layered hero section to section-wise animations to a fixed vertical slider that updates as you move. This tutorial is fully detailed, step by step. And whether you're watching in English or in your native language, you can enable auto-translation from the settings menu and switch between translated or original English anytime. It takes effort to make videos, so if you're liking my content, press the like button and subscribe to the channel. It motivates me to make more videos. Now that you've seen the big picture, let's move into the actual breakdown and start from the foundation, the HTML structure. All right. Let's now begin breaking down the HTML structure of our landing page. This part is extremely important because how we plan the HTML directly affects how smooth our CSS layout feels and how flexible our JavaScript animations become later on. We'll go step by step from the body tag through each section and understand how the visual design is powered by clean semantic structure. So let's start. We begin inside the body tag. The very first element we create is the header. We give it a class called header. This header is fixed, meaning it stays at the top while we scroll the rest of the page. It also contains all the navigation and branding. Inside the header, we place a nav tag with a class called navbar. This gives semantic meaning. We're telling the browser and screen readers this part is the site's main navigation. Now inside the navbar, we have a wrapper div with the class header container. This is our flex container. It aligns all child elements like logo, burger menu, and menu links side by side. Next, we add our brand logo. This is wrapped inside an anchor tag using class brand. Inside it, we embed an SVG, a scalable vector graphic logo, which ensures sharpness across devices. Below the logo, we place the burger menu. This is a div with class burger, which contains 3 span tags inside another wrapper. These span tags are styled as horizontal lines, giving the visual look of a burger icon. We will use JavaScript later to animate and toggle this icon between open and closed states. Now after the burger, we define the full slide-out menu. This is a div with class menu. This menu contains 2 main parts. First, the menu header, which shows the brand logo again, along with a close icon using another burger structure. Second, the menu inner list, which includes all navigation links. Each link is wrapped inside a list item with class menu item, and inside that, an anchor tag using class menu link. The links we've added are equipment, about us, and blog. Then, outside the menu, but still inside the header container, we add a block called menu block. This holds the account button, which uses an icon from Boxicons followed by the label account. This area stays separate from the navigation list, giving a secondary action space. Now finally, after the full nav setup, we add one more div called header backdrop. This acts as a semi-transparent overlay behind the menu when it opens, and it helps us detect clicks to close the menu using JavaScript. This entire header section is built to work across devices, with both desktop and mobile-friendly structures, and it gives us full control to animate its open-close states, sticky behavior, and scroll effects later. Now we move into the main section. Inside the main tag, We start with the hero section. Using class hero section and giving it an ID called section 00, this section is the cinematic entry of our page. It includes multiple layers, each designed to animate and move independently. First, we have a wrapper div called Hero Image Wrapper. Inside it, we add 3 image tags, one for the sky, one for the mountains, and one for the man standing. These 3 images are layered visually using CSS, and later we'll animate them with scroll using G-Sap and ScrollTrigger to create parallax effects. Next, we add the hero content. It's a div called Hero Content. Inside it, we place a subtitle using heading 5 tag with class hero subtitle, then a large heading using heading 1 tag with class hero title. This title is split into 2 span tags, so we can animate each line separately. And finally, we place the call to action. This is an anchor tag with class hero action. It includes the text scroll down and a downward arrow icon. Clicking it takes us to the next section using an ID anchor link, and that completes our header and hero HTML structure. Everything here is built with clarity, from class naming to nesting order, so that our CSS layout and scroll animations remain modular and readable. We start by creating a section element with class content section and one more class called section. This tells our CSS and JavaScript that this part is a scrollable block that we might animate later. Inside this section, we place a wrapper div with class container. This helps us limit the content width on larger screens and maintain consistent side paddings. Now, inside the container, we repeat a structure called content wrapper. Each content wrapper represents one scrollable step or chapter in the story, and we assign it a unique ID, like section 01, section 02, and so on, which helps us scroll to them, pin them, and animate them individually using G-Sap. Each content wrapper contains a div with class content row. This row holds 2 main parts, the image and the text. Let's look at the image first. We use a div with class content image, and inside that, a regular image tag. This shows a visual representation of the step, for example, a map, a backpack, or a hiking gear illustration. We'll later animate these images to scale in and fade on scroll. Now on the other side, we have the content block. This is a div with class content. Inside this, we place 3 key elements. First, the subtitle. It's a heading 5 tag using class content subtitle. It also includes a nested span with class counter, which shows large step numbers like 01, 02, or 03. These counters are absolutely positioned and faded into the background, giving a dramatic oversized number behind the actual text. Then comes the title. Some sections have an extra heading, using heading 2 and class content title. We split this title across 2 span tags again, just like the hero title, so we can animate each word or line separately using stagger effects. After that, we add a paragraph tag using class content copy. This holds the main text, explaining the tip, story, or information for that step. And finally, we add an anchor tag with class content action. This is a call to read more, styled with a small arrow icon to hint forward motion. We repeat this same structure 3 times, with different image sources, titles, and counters, to create a complete scroll-based story. Now let's move to the bottom section of the page, our slider navigation and footer. First, we have a nav tag with class slider. This slider is placed outside the content, and it's fixed on the right side of the screen. It acts like a quick navigation bar, allowing the user to click and scroll to any section instantly. Inside the slider, we again place a container. Then an unordered list with class slider list. Each list item includes an anchor tag that links to section IDs, like section 00, section 01, and so on. Below the list, we add a div with class slider progress. Inside it, we create a nested div with class slider progress bar. This bar will grow in height as the user scrolls, showing how much of the story has been explored. And later in JavaScript, we animate this height using G-Sap and ScrollTrigger. And finally, we wrap the page with a footer. We use the footer tag, then add a container and a wrapper div with class footer row. Inside this row, we create 3 columns. The first column is for branding, using class footer column logo. It contains the same SVG logo again, a short brand message, and a copyright notice. The second and third columns both use class footer column link. Each one has a heading, using class footer heading, and a list of anchor tags as useful links such as about, write for us, contact, or press. This entire footer is fully responsive and stacked vertically on smaller devices, and it gives the finishing structure to our page. Now at the very end of the HTML, we include all our JavaScript files. We first load the Lenis Scroll library. Then we add 3 G-Sap plugins, the core library, ScrollTrigger, and ScrollTo plugin. And finally, we load our custom script file, where all animation logic is written. And with that, our entire HTML structure is complete. It's built with clarity, reusability, and animation-friendly nesting, so that our CSS and JavaScript can work cleanly on top of it. Now that our HTML is fully explained, let's move to the styling and understand how the layout, backgrounds, layering, and responsiveness is handled using modern CSS. All right, developers, let's now dive into the CSS. We're going to read and understand this file, not as a list of styles, but as a story of how our layout is visually structured, layered, and animated. I'll go from top to bottom, selector by selector, and explain only the important logic behind each one. Not every single property, but why it exists and how it contributes to the final look. Let's begin. Right at the top, we import 2 web font families, Bentham and Roboto, both coming from Google Fonts. Bentham is used for our headings, giving us a classic serif look. Roboto is for all body text, clean, readable, and modern. Then we also import box icons, a lightweight icon library used in the header. Now we begin the reset. The star selector, along with before and after pseudo elements, sets everything to have 0 padding and margin by default. We apply border box sizing, remove list styles, and disable text decoration. This gives us a clean slate, so our layout is fully in our control. Next is the HTML tag. Here we inherit box sizing, set scroll behavior to smooth for anchor link transitions, and apply full available height for WebKit browsers. Then we move to the body. Here's where we define the base font using Roboto. We also apply a dark background, deep blue, and set the text color to a slightly desaturated bluish gray. There's also a class called Overflow hidden, which we toggle from JavaScript to lock scrolling when the mobile menu is open. Now the main tag. It's simple, just overflow hidden, used to prevent unwanted horizontal scrolls caused by pinned animations. Next, the anchor and button elements. We remove all native borders and outlines, set user select to none for clean interactions, and ensure everything is cursor pointer by default, especially useful for SVG-based buttons. Images and videos, we make them block elements. They scale to max width and maintain aspect ratio. Object fit cover makes sure media always fills its box without distortion. Now heading tags, from H1 to H6, we override their default font family to Bentham. This instantly gives us that travel magazine feel. Then comes the container class. It limits the width to around 1400 pixels, adds side padding for breathing space, and centers all content using auto margin. And that covers the base, the invisible groundwork that controls consistency across every section. So let's move to the header layout and continue our styling breakdown. The dot header selector represents our main navigation bar wrapper. It's set to fixed position, locked at the top, so it stays visible during scrolling. We give it full width, auto height, and a higher Z index to ensure it always sits above other layers like content or background images. It also has a smooth transition applied, so whenever it changes background or padding on scroll, it feels fluid. Then comes dot header container. This simply handles internal padding on the left and right, keeping our layout aligned within the page container. When we add the onScroll class to the header, a new style is applied dynamically via JavaScript. We give it a transparent dark background and blur using backdrop filter. This creates a beautiful glass morphism effect as you scroll down. Next, the .navbar. This is the visible bar inside the header. We give it vertical padding and apply a soft box shadow, creating a subtle depth when it's in its default state. Inside it, the header container is set to flex. Row direction by default, so all nav items sit in a line. Items are vertically aligned to the center and spaced to the left using Justify Content Flex Start. Now the brand logo. It's inside a div called .brand, and we target its SVG to limit max width. That ensures it remains crisp but never stretches too large on wider screens. Let's now look at the mobile menu, beginning with .menu. This is a fixed position side drawer. It sits off canvas to the left by default using Transform Translatex -150%. We give it full height, dark background, and hidden overflow, so when it's not active, it remains invisible. When the class menu is active as applied, we transform it to 0%, sliding it into view. This class toggle is triggered from our burger button. Inside the menu header handles the top bar, with space between for logo and close button. Then comes .menu inner, a vertical flex layout with row gaps to separate each menu link. The .menu link handles each text link inside the drawer. We give it medium font weight, white color, and a hover transition. It looks clean and modern. Then .menu block is used for social icons or secondary links. We align these to the right using margin left auto, and add some spacing between each. Inside that, the menu block link holds each icon and label. Again, flex layout, small gap, bold font. We also target the icons using .bx and increase their font size to stand out. Next, let's talk about the burger. The .burger class controls the hamburger icon, used to open and close the mobile menu. We use relative positioning, padding for clickable area, and apply smooth transforms, including rotation for the animated lines. Each of the 3 lines is a span with the class burger line. They're absolutely positioned, rotated on interaction, and styled with a white background and rounded corners. On click, we apply is active to the burger. That triggers visual changes. The first and third lines rotate to form a cross, and the middle one fades out. To complete the mobile menu experience, we use a backdrop overlay called Header Backdrop. This darkens the background and prevents interaction with the page behind. It's hidden by default, but becomes visible and semi-transparent when menu is active is applied. This entire setup is fully responsive and adapts beautifully across mobile, tablet, and desktop, but on larger devices, we take a different approach. In media queries for screen widths above 992 pixels, we hide the burger and convert the menu into a horizontal layout placed directly inside the header. We reset positioning to relative, remove transforms, and use Flexbox with column gaps to space out the links. We also change hover colors for desktop users, giving them a highlighted effect on mouse over. This makes our header clean, animated, and fully functional for all devices. And that wraps up the navigation section. In the next part, we'll explore the hero section and understand how we've layered the sky, mountains, and the man image using only CSS. So let's move to the hero layout and image layering. We start with the .hero section. This wrapper is set to relative position, which gives us a reference point for absolutely positioning the layers inside. We also apply a bottom padding of 140 pixels to make space for overlapping content, and set overflow to hidden to make sure nothing spills outside unintentionally. Next, we use 2 pseudo elements, before and after. The before pseudo element covers the entire hero section with a diagonal dark gradient. This is placed behind the images and gives a subtle fade from top to bottom, almost like atmospheric haze or cinematic tint. The after pseudo element adds a second gradient at the bottom, fading from transparent to solid dark blue. It creates depth and transition into the next section below. Together, these gradients frame the imagery and make the content feel grounded. Now we reach the .hero image wrapper. This is the main container for all our visual layers, sky, mountains, and the man image. Inside this wrapper, all elements are flex aligned to the top left by default. The images themselves follow a very deliberate layering order. Let's break them down one by one. The sky image is the first and lightest layer. We give it full width, set object fit to cover, and apply a vertical translation upward so only part of the image is visible. It's also set to 100% viewport height, ensuring it always covers the full screen height. Next comes the mountains image. This is placed directly above the sky using z-index of 1. We give it a negative margin top so it overlaps dramatically, creating that classic layered landscape effect. Again, height is set to 100 viewport height. Then comes the man standing image. This is our focal point. It's brought to the front with z-index 4, given a fixed height of 330 pixels, and positioned slightly higher using a negative margin. This helps the person appear grounded in the mountains, but still prominent enough to draw user attention. Now let's shift to the content itself. The .hero content is positioned absolutely within the hero section. We center it horizontally, limit the max width, and push it downward by 20% of the screen height, so it aligns visually with the landscape. Padding is added for horizontal breathing space. Inside it, the hero subtitle appears first. This is a small uppercase label, styled with letter spacing, bold weight, and a yellow highlight color, giving it that premium expedition feel. We also add a decorative horizontal line before it using a pseudo element, a thin strip of the same yellow, placed inline. After that, we reveal the main title. The .hero title is large, serif-styled text with white color and tight spacing. Each word is wrapped in a span, allowing us to target and animate them individually later using JavaScript. Then comes the call to action row. We use flex to space out text and a small animated icon, typically a downward arrow that pulses up and down. This is achieved with a keyframes animation called scroll down arrow, which moves the icon vertically in small bouncing steps. This entire hero section is fully responsive. In smaller screens, all image margins and transforms are adjusted, so the layering effect still looks natural and the man remains centered visually. Then in larger media queries, we increase font sizes, reposition the content higher, and realign everything to match the desktop layout. The key here is balance. We keep the artistic mood without sacrificing clarity or responsiveness. This completes our visual introduction. In the next part, we'll explore the content reveal section and explain how each text image block slides and animates as we scroll down. So let's move to the scroll-based content section now. We start with the section wrapper itself, .content section. It's given a relative position and a z-index of 5, ensuring it stays above the layered hero background. We also apply a negative margin top of 50%, which visually pulls this section upward to overlap the hero section slightly. This helps create that seamless scroll transition effect. Inside this section, we use .content row. It's a flex container set to column direction by default, with a gap of 60 pixels between content blocks. This gap gives breathing space between each storytelling unit. Each of these units is a .content wrapper. For all but the last child, we apply a bottom margin, which increases on larger screens, so spacing remains balanced regardless of screen size. Now each wrapper typically includes two parts, the image on one side and the text content on the other. Let's look at the image container first, .content image. It's full width by default, and the image inside is set to cover the container using object fit. We apply a smooth transition on all properties, which comes in handy when animating on scroll later. In desktop view, we resize this image to a fixed width like 560 pixels, ensuring consistency and readability. Now to the .content content. This is the text column, given some padding on larger devices for alignment. It contains the subtitle, title, copy paragraph, and a small action link. Starting with .content subtitle, this is a yellow highlighted uppercase label with letter spacing and flex alignment. We also include a horizontal line before the text, just like the hero subtitle. It has a smooth transition and a nice vertical spacing. Now here's something interesting. Inside this subtitle, we also add a giant decorative number using a nested span with class .counter. This appears behind the text with low opacity and huge font size, giving a stylish timeline or chapter number feel. We absolutely position this number in the center left, then shift it using transform to align perfectly. And again, we use a transition so it animates softly when needed. Next comes the title. .content title uses a large white serif font with a bit of bottom spacing. Each word is wrapped in span again so we can animate them individually using G-Sap. Below that, we add the main paragraph .content copy. This is a clean, readable block of white text, set with a line height of 32 pixels for smooth readability. It's kept light in size and weight for balance. And finally, we add the call to action row, .content action. This is an inline flex element with a yellow color, an icon on the right, and a small hover animation. On hover, the gap between icon and text increases from 16 to 20 pixels, creating a soft bounce effect using transition. All of these blocks animate on scroll using G-Sap later. But even without animation, the spacing, layering, and contrast here already feel modern, readable, and scroll-ready. For desktop view, we update layout logic using media queries. At larger breakpoints, the row becomes horizontal. Images and content take up half of the row. Every alternate block reverses the order, so we get a zigzag timeline pattern. Font sizes and counters grow larger. Padding is adjusted for balanced layout. These layout tweaks bring dynamic variety to an otherwise repetitive structure, helping your storytelling feel more alive. And that completes our content reveal section breakdown. Up next, we'll move to the footer section and explore how we keep the branding strong and flexible across all devices. Let's move to the footer. We begin with the footer tag. It has top and bottom padding, 100 pixels at the top and 50 at the bottom, to give the footer room to breathe. Inside it, we use a wrapper called .footer row. This is a flexible layout that adjusts based on screen size. By default, it uses flex layout in a column direction with a gap of 50 pixels. This helps stack all the columns one below the other for small devices. On larger screens, this row switches to a horizontal flex layout. We increase the gap from 50 to 100, then finally 200 pixels, ensuring even spacing between footer sections no matter the screen width. Now inside this row, we have multiple footer columns. Let's begin with the footer column logo. This column spans the full width and uses flex layout in column direction. It includes a footer logo block with bottom margin, a paragraph with white color and readable line height, and finally, a copyright line styled in smaller font and pushed to the bottom using margin top auto. This auto margin ensures the copyright always stays at the bottom, even if the text content above it changes in height. Next, we have other columns like .footer column link. These are smaller sections containing a heading and links. The footer heading is styled in yellow color, bold weight, and increased font size. We also apply the Roboto font family here to differentiate it from titles above. Each heading has spacing below it, followed by the footer links list. The link list is a vertical flex container with small gaps between each item. Links inside use white color, readable font size, and line height of 32 pixels. The spacing is just enough to make them tappable on touch devices while still fitting in compact space on desktop. This structure, heading followed by link list, makes the footer highly readable and skimmable for users looking for quick navigation. What's nice here is that all footer blocks use responsive logic. As screen size increases, the layout shifts from stacked columns to side-by-side rows, all while maintaining consistent visual hierarchy. This is done entirely through flexible containers and media queries without relying on heavy grid structures. And that's what makes this footer section effective: simple layout, scalable spacing, and visual balance. Now the final piece on this page, let's move to the vertical slider section on the right side that scrolls through page anchors with progress tracking. We start with the dot slider selector. It's set to position fixed, meaning it stays in place even when the page scrolls. It also uses a high Z index so that it always appears above other content. Inside the slider, we reuse our dot container but with zero padding and a right alignment using Justify Content Flex End. The items inside are spaced using a gap of 32 pixels. Next comes the actual list called dot slider list. This list is a vertical flex column with gaps of 40 pixels between links. This makes sure each anchor link has enough breathing room and doesn't feel cramped on the sidebar. Each item link is styled with white color and bold weight, ensuring visibility even over background images. Right next to the links, we have the progress bar. The outer container is a thin vertical line with subtle white transparency, and inside it, the active progress bar fills up as the user scrolls. Let's quickly understand how this layout adapts to different screen sizes using responsive media queries. The entire design follows a mobile-first approach, which means we start with base styles for small screens, Then scale up the layout using min-width breakpoints. We use 5 main breakpoints: 576 pixels, 768, 992, 1200, and 1400 pixels. Here's how the layout evolves across screen sizes. Starting with small devices like landscape phones, we make small tweaks to font sizes and paddings, especially in the menu and hero images, to prevent overflow. Then for medium devices like tablets, we increase font sizes for the hero subtitle and title, ensuring better legibility on slightly wider screens. As we move to larger screens, around 992 pixels and above, we transform the entire layout into a more advanced structure. The burger menu is hidden and the full navigation is displayed using Flexbox. We also rearrange image positions, introduce more spacing, and adjust hero content placement to better utilize desktop space. For extra large and ultra-wide screens, we fine-tune the inner paddings, text sizes, and row gaps. Content blocks get more breathing room, and the subtitle counters are pushed further out to maintain alignment aesthetics. The entire responsive system is scale-oriented and modular. We don't rebuild components for every screen size, we only update what's necessary using minimal overrides. This keeps the CSS efficient and the layout stable across all devices. And just like that, the design gracefully shifts from mobile to widescreen without breaking the experience or compromising performance. Let's move to the JavaScript onload animation powered by G-Sap. Now we begin the most exciting part of this layout, the JavaScript-powered animation and scroll behavior using G-Sap. So let's break down every line, every function, and every trigger to understand what's happening here. We start with the main event listener, document.addEventListener for content loaded. This means the entire script will only run once the HTML document is fully parsed and ready. It ensures that all DOM elements exist before we try to select or animate them. Inside this event, we first register 2 GSAP plugins, ScrollTrigger and ScrollTo plugin. Registering plugins is a required step, so G-Sap knows to include them during animation execution. Next, we define variables for the header menu behavior. We select the header element. Then inside it, we look for the burger icon. We also grab the backdrop behind the menu and the close button inside the menu. We define a reusable function called toggle menu that takes a Boolean value, true for open, false for close. Inside this function, we toggle the active class on the burger icon and the header. We also add or remove an overflow hidden class on the body to prevent background scroll when the menu is open. If the menu is open, we also add a custom data attribute called data Lenis prevent to temporarily stop smooth scrolling. We then add click events. If you click the burger, the menu toggles open or closed. Clicking the backdrop or close icon will always close the menu. This gives us full control of the mobile navigation using just a few lines of logic. Next, we add a scroll event on the window. Every time the user scrolls, we check the height of the hero section. If the scroll distance is more than half the height of the hero, we add a class to the header called onScroll. This class triggers a blur background effect in CSS. Now comes the smooth scroll integration using Lenis. We initialize a new instance of Lenis, which is a library that replaces default browser scrolling with smoother behavior. We attach an event listener to Lenis that triggers ScrollTrigger.update. This keeps G-Sap scroll animations in sync with Lenis's scroll frame. Then we connect Lenis's internal animation frame method to G-Sap's ticker using GSAP.ticker.add. This runs the Lenis scroll engine on every animation tick from G-Sap. We also disable G-Sap's lag smoothing to ensure perfect timing with the custom scroll. Now let's talk about the entrance animation, the hero timeline. We create a new timeline using GSAP.timeline. We target 4 key elements: the hero subtitle, each span in the hero title, the hero action link, and the items in the sidebar slider. We animate these elements from opacity 0 and offset in the Y direction by 100 pixels to fully visible and 0 offset. The animation plays in a sequence using stagger. Then we animate the slider progress background to fade in with a delay of 1 second. This gives us a beautiful onload animation that introduces the key content elements with motion. Now comes the parallax scroll effect in the hero. We create a new G-Sap timeline with ScrollTrigger. This ScrollTrigger tracks the hero section from top to bottom. We set scrub to 0.5, which means the animation follows the scroll position but with slight delay. Inside the timeline, we animate 4 things simultaneously. The sky image moves down by 1000 pixels. The mountain layer moves up by 300 pixels. The man image moves up slightly by 100 pixels. And the hero content fades out and moves down by 450 pixels. This creates a layered scroll effect where each visual moves at a different speed, giving us a dynamic parallax animation. Now let's move to the content section animations. We select every content row individually. Inside each row, we get the image, subtitle counter, subtitle text, title spans, description, and action button. We create a new ScrollTrigger timeline for each row. This timeline pins the row in place and animates its content in sequence. We define the trigger point to start when the center of the row is slightly above the center of the screen. Then we animate all elements from invisible and offset to fully visible with natural upward motion. The counter fades in separately. The image scales down from 1.5 to 1 while fading in. This gives each content block its own spotlight as the user scrolls through the page. Finally, we animate the vertical progress bar in the sidebar. We use GSAP to fill the slider progress bar to 100% height as the user scrolls the page. We set ease to none for linear progression and use scrub to bind it to scroll movement, and that's it. With just a few timelines and triggers, we've turned a static layout into a fully animated scroll journey, featuring smooth entrance animations, layered parallax effects, and section-wise reveal sequences. All thanks to the power of G-Sap and ScrollTrigger. And that's how we built a stunning, modern hiking landing page with smooth scroll, animated sections, and scroll-triggered effects, all powered by G-Sap and a clean semantic layout. We explored everything from responsive CSS to dynamic timeline animations, and even layered parallax scrolls that react to the user's movement seamlessly. But here's the most powerful part. You can customize everything. You can control each G-Sap timeline, trigger animations with button clicks, sync scroll with your own UI events, and even define how animations behave on different screen sizes. It's not just a landing page. It's a modular system of scroll-linked animations that can be reused in product reveals, brand storytelling, or even portfolio projects. If you're curious about how to link GSAP timelines with external UI controls, or how to trigger animations dynamically, let me know in the comments. I might just make a bonus deep dive video on G-Sap ScrollTrigger customization and timeline control techniques. It takes effort to make videos, and if you're liking my videos, press the like button and subscribe to the channel. It motivates me to make more. And remember, YouTube auto translates this video into multiple languages. You can switch to your native language or back to English from the settings menu. See you in the next video.